Hey everyone. So this video is about the 6th grade standard equations and expressions, or EE4, right? And this standard asks students to be able to identify equivalent expressions. An expression is a way of saying something, and an equivalent expression would be another way of saying that same thing. So here, for example, I see they're asking us to choose all the expressions that are equivalent to this. Right? So what are all the other ways that we can say this? All right, and when you look at this, and I hope you see what I see, which is I see 4, and then next to parentheses, that means groups of, 4 groups of 2x plus 3, or 4 times 2x plus 3. So another way of thinking about this is to write it down like this. I have 2x plus 3, and another group of 2x plus 3, and another group of 2x plus 3, and another group of 2x plus 3, right? That is going to be 1, 2, 3, 4 groups of 2x plus 3. And when I write it this way, immediately I can tell that option D is an equivalent expression, another way of saying 4 groups of 2x plus 3. I can continue here. I'm going to go ahead and add these up and see what I get when I put all 4 of these together. If I add up all the like terms, here are all the constant terms, a 3 plus a 3 plus a 3 plus a 3, I get a 12. And over here, if I add up all the x's, there's 2 x's plus 2 more x's plus 2 more x's plus 2 more x's, is a total of 8 x's. So this shows me that I have 8 x's plus 12, which points out I can see another equivalent expression. That's another way of saying it. Now, I could have done that through multiplication, but we'll explore that later. What I want to do now is take a look at some of these other choices, right? Like 2 groups of 4x plus 6. Would that be the same thing? If I wrote 4x plus 6 and 4x plus 6, and if I added these 2 groups together, what would I get? Well, I would get a 12 out of the constants column, and the x column, 4x plus 4x, is 8x. So I see that that is another way of saying the same expression, or expressing the same amount. Let's check out C. All right, let's change colors here. C shows a 4x plus 3 plus 4x plus 3. You know, you're starting to get good at this. You can probably think that 4x plus 4x would be 8x's, and 3 plus 3 would be 6. That is not the same quantity as 4 groups of 2x plus 3, or the same as this. This last one is a little trickier, right? So C's out. Sorry, I should back up here. C is out. I'm going to cross that out. That's 8x plus 6. This last one is a little trickier here. If I write these down, how would I add all these together? Well, you might remember that you can group like terms. You can group like terms. So what we can do is we can write the 6x and the 2x together, right? This guy and this guy together. And we can also write the 10 and the 2 together. And we can add these together. They are similar terms. We call them like terms. And we can add these 2 together. They are like terms. So 6x's and 2x's make 8x's. And I have this plus sign right here. I'm going to add this other set over here. These are also like terms. These are both constants. I can add the 10 and the 2 and get 12. So 8x plus 12. It turns out that E is also similar. So E, D, B, and A are all correct answers. Let's check out one more option. And this time, instead of multiplying or adding like terms, in this choice, or in this set, we're going to see about breaking apart a total, right? So this says, show all the expressions that are equal to 12x and 24. So it looks like here all the x's have been combined and all the constant numbers have been combined already. So we have to think about breaking them apart. Or we can simply check each one of these, right? I don't know if that's equivalent or not. So how would we do that? Well, I could check. Let's do the first one. We'll do a check, right? Let's say I have 2 groups of 6x plus 8. Now, instead of listing them all out, I am going to kind of take a shortcut and multiply. Instead of adding 6 plus 6, I'm going to do 2 times 6. That's 12x. And I'm going to say I have 2 groups of 8, right? So 2 groups of these, 8 plus 8 would be 16. That's called the distributive property, right? We can multiply across this addition problem to get a total. And 12x plus 16 is not equivalent to 12x plus 24, so this one is out. Let's try that distributive property trick again. Let's try B, 4 groups of 3x plus 6. Now instead of writing this 4 times, I'm just going to use multiplication. 4 times 3 is 12x, so far so good. And 4 times 6 is 24. There we are, 12x plus 24. Looks like B is good to go. Now look at this one. I could write all these out and add up all the x's, but I'm going to try and take a shortcut here. There are 4 groups of the same thing. So I'm going to write 4 groups of 3x plus 6, right? Instead of writing this plus this plus this. And hey, look at this. Isn't this is just what we did over here. 4 groups of 3x plus 6. B and C are the same. 4 groups of 3 is 12x, and 4 groups of 6 is 24. B and C are equivalent expressions. They are both equal this guy right up here. It's supposed to be a little star. Didn't come out so well, did it? All right, let's try D. Let's just do it right here in the browser instead of rewriting anything. 2 groups of 6 is 12x, and 2 groups of 12 is 24. Oh my gosh. I'm just going to rewrite that so you can see what I just did. I did a 6x plus a 12 and another 6x plus a 12. That was 2 groups of 6x plus 12. That was 12x plus 24. This is also equivalent to this expression up here. And this last one, again, we see the terms broken apart, right? But I'm going to go ahead and add it real quick here. 10x plus 2x, if I put all the x's together, I'll get 24. If I put the constants together, 10 and 24, I would get 34. Uh-oh, that is not correct. So it looks like this last one is out. E is not correct. That has a constant of 34. Okay, so hopefully these tricks will allow you to use the distributive property and combining like terms to identify all equivalent expressions.